All right, let's continue. This is day 3. So now we need to do an hour and a half self-test. Excuse me. So that every 5 self-tests, or every 5 studies, we have a self-test. Instead of it being every other, well, instead of being every, it's like every 7.5 hours, we spend an hour and a half self-testing, instead of every what? 200 something, instead of like every 3 hours or something. It's just too often, I think. Okay. Oh. It totally messed up, I guess. Okay, yeah, I guess it just fucked up. Oh, not again. Is it because I'm just doing the wrong hotkey? Yeah, like, what is this? Do I just need to refresh? Yeah, it's just bugged. Bro, is Perplexity just sucking dick right now? What is happening? Why is it so bad? Okay. I don't normally like this personification stuff, like act like you're a whatever, but I'm gonna try. Can be expensive depending on the element type and count. Example. Standard, well, to handle cheap and expensive version, well, assuming all copies would be expensive and would be unnecessarily expensive, can remove this cost by passing by reference const reference if we want to treat the array as immutable. Let's just access the values where they are in memory from the receiving function. 17.1. Standard array shows many members with standard vector, like dot size, dot at, can be subscripted. What else? Compared to C-style arrays, standard vector implemented as a class template has member functions. So you can probably still do get with a C style. Like, can we do, what if we did int x I don't even know what that would look like. 3. It's of size 3 and it's 1, 2, 3. Okay. And then what if we did standard get x, or standard get 1 x. Still doesn't work. So it doesn't like C styles. Okay. As member functions, including dot size, dot at, what else? I mean, I guess we wouldn't use pushback or popback because we can't change the length. And those could, well, popback wouldn't reduce the capacity, but pushback could increase it, which we can't do apparently. Haven't tried it yet though. And data and other functions that can use it, like standard get, index, standard size to index. What else? Standard S size. What about and x, and it has 2, and it's 1 and 2, and then we say standard S size x. No. Might not be usable with C style arrays. I think the main difference. Well, what else? Is that C style arrays apparently decay to pointers? I mean, we can use a pointer to get, so is it decaying to individual elements that we each can reference with a pointer? Something like that. I'm not really sure exactly like why though. Well, standard array doesn't, I think, since its data member is a C style array. And maybe that prevents decay? I'm not sure. All right, we'll say 16.10. Vector size is the length, i.e. the amount of, or the quantity of valid elements. Capacity is the potential Well, is the amounts that are that memory. Well, what are we doing? So we're allocating memory, or that memory is allocated for. Well, currently being used for. But no, I guess it's not. It's that memory. Well, that allocated memory is holding values for. Vector capacity is the amount of elements. I guess it's really the quantity of valid elements, while capacity is the amount of elements that memory is currently allocated for. I.e., we might have memory allocated for 10 elements, but only have 3 valid elements. Capacity equals 10, length equals 3. 16.8. A for loop using a range base? Okay. The fuck is happening here? I don't know why. Okay, I don't know what happened. While index is less than pop. You write a for loop over vector using range base for. For loop. Range based for loop. For const auto reference value or well, element x. That's so much easier. Modern C++. I don't know what version. Well, we can efficiently return standard vectors by value using move semantics. I.e., because standard vector is a movable type and it's a temporary when returned by value, we can transfer data from one object, well, from one object to another. Is that how it works? Or from being owned by one object to being owned by another. Removing the cost of value copying. Point 2. Standard vector size using dot size. And capacity with dot capacity. i.e. v.size or v.capacity for capacity. (15.8) Friend functions break encapsulation by giving non-member or member functions or other classes member functions access to this class's private data private members, private protected members, i.e. are giving the public specific members of the public access to what the public normally can't access. Which opposes the principle of encapsulation. Careful about who you're friending. Static member variables cannot be can be declared inside a class definition, but must be defined outside it unless made inline or const expression for some types. Their values are shared among all objects of the class and stored in one place in memory. If updated by one class object or a class's static member function, all of the class's objects, well, the value updates and is usable and reflected whenever used for any of the class's objects. 15.4 Class destructor is called when a class object is destroyed or leaves scope, assuming it isn't a static local, which wouldn't call the destructor because the local wouldn't be getting destroyed. And static locals persist until program end. I don't like the feeling. A little, I don't know if a hair moved or if I have a fucking spider infestation. I don't think I do. I just have hairy, like my legs are fucking hairy. Get some Joe Biden action real quick. See, these things are fucking hairy, yo. So I can never tell if it's just a hair moving, especially when it gets cold in the apartment, or if it's actually one of the couple spiders I found these past days. (15.1) The hidden this pointer points to the implicit object. The class object whose member functions contain the this pointer. 14.14 Copy constructor is invoked, called when creating a class object with an initializer of another object of the same class. Looks something like, well, I mean, we could just make one, right? Class test And we could say, well, could we say, we could say one thing. We could say this is test. Or better yet, for const variables, const objects. Well, yeah. Objects that can't be assigned after initialization. Class best one, sure, or we could say best public, best const, best reference, best. Private, sure. Int, joke. Joke. Joke is initialized to be best joke, or best dot joke. .9 constructor. For manual initialization, because it lets us use list initialize or a list and initializer list to initialize all member variables at once instead of one by one via copy assignment, right? Because if we call it a function, we can't initialize them if they're default or value initialized. So sure. 14.2. A class. All right. Classes and structs are the same, except conventionally, structs don't have constructors or don't have member functions, and structurally, classes default to private access, while structs default to public access. Technically, they're the same in all other regards. The structs are used to package related data together, like a finger struct that contain, or a hand struct that contains a 5-element finger array, standard vector or standard array. Instead of naming each finger distinctly, which might not be desired, which might be unwanted. .7, 13.10. Access a member of a struct through a pointer using the arrow operator. This guy. Instead of putting the struct in parentheses, dereferencing it outside parentheses, then using operator dot, the member selection operator. Arrow operator is more concise. Ow! Man, fucking spiders are just biting me up. I can't believe it. Or it's more likely my hair is just getting freaking pinched. The syntax to declare a color enum class is written below. Okay. Oh, an enum class. Enum class color red, blue. Okay. Number 2. Enum values. Oh. Enum values placed in global scope. Create naming. Well, Well, is it name conflict or or just shadowing? We could say either way, because we could say enum color red, blue, black. Sure, right? And then we could say int main int x or int red 3. And then we could say red. Is it? Oh, it's the int. Yeah. But then we would have to say red. Well, create, I mean, that we get shadowing, right? But what if we also did, would red? That didn't matter, okay. Expression preceding parentheses of a parent call must have a pointer to function type. Oh, issues because the redefinition. Okay, so what if we did bop and we did bop? And we did bop and we did bop. Cool. Well, what if we just did? We get redefinition. Name conflicts between functions using the same identifier and get shadowed by local variables with the same identifier. Like compiler error due to redefinition. Well, what if we do here? Oh. What if we did it this other way? Excuse me. Open 10. I could just do an overload now. This one takes a const and pointer called value. Hold. If value. Hold. Then we could do the same thing. Void print value. Int value or const int reference value. Instead, I did an overload. Show both. Oh, you fucker. value of a null pointer is, well, is it a pointer that points to nothing? A value of the pointer type, which best matches, which chooses overloads using a pointer parameter instead of an int parameter, like 0 or null. Used to assign or make pointers point to nothing and be evaluatable, and return false when evaluated as a condition. 12.3. Point to non-const L-value references. Non-const L-value references can only bind to modifiable L values. In contrast, const LA references can bind to L values, modifiable and non-modifiable, and R values. Point 1. Const expression. I mean, a const before the function doesn't really mean anything, right? I mean, it just means that the temporary is const, but the temporary can't be changeable anyway, and it's only, I mean, it doesn't make any difference. Like, so, const expression for a function, well, in the context of functions, const expression means the function evaluates at compile time if it only takes constant expression, or if its arguments are constant expressions, if test arguments are all constant expressions, if it doesn't call, well, if it only calls constant expression functions, and if it's called in a context that requires compile time evaluation. Const, I believe const is mainly used for member functions, not non-member functions. Since, unless we're returning const references or const pointers, or const pointer to const pointer to consts values. Maybe const functions are more optimizable by the compiler, but I never see them. They're usually const expression if they can be made const expression, and that's it. 1.6, sure. Sure. T max, T min, T max. Return min greater than, or min less than, well, min less than max. Max, min. Oh, oops. Somehow this is the conditional shit, but I'll prefer this. Because this whole thing evaluates properly. So in this case, is the min less than the max? If the min is less than the max, then return max. If min is greater than the max, then return the min value. Say function template right there, Sonny. 1.1. Functions cannot, two functions cannot only differ by return type. They must differ in parameter, count, order, or type. Order, type, identifier, or for member functions with reference qualifiers. 10.8. Type of auto that double, because X's initializer is a double. Literal. 10.6. Static cast to an int 3.14. Oops. Dynamically, well, I guess I don't know. I mean, what's it? Hold on. The types of casting. They're static casts. Is that even a thing? Dynamic cast? Yeah, I don't know how that works. Okay. Statically cast. Well, really, it's explicitly convert double literal 3.14 to integer 3. 10.1 to 10.5. Nearing conversions can be dangerous because they can yield data loss, i.e. like that static cast in 10.6. It's technically narrowing because integers can't represent all double values. And we're in fact losing the 0.14. Losing value. But we're explicitly telling the compiler via static cast that we're okay with that. For implicit conversions, oh yeah, I think that's fine. If we aren't expecting it, narrowing can be dangerous. Okay, 9.6. Assert evaluates at runtime, while static assert evaluates at compile time. Preventing yielding a compilation error if returning false. If its condition is false. Assert is also compiled out if ndebug defined for release builds. 1.5. Oh, so we might want to include conditions 2 if wanting to keep checking in release builds. To read an int, meaning we're trying to extract to an int, but you put in hello. If we're extracting input to an integer, but the user enters hello, either a C-style string or C style string array of characters is attempted to be stored but should fail, and standard character input should return false since it would be flagged. It's failed. Since it would be flagged for input failure, or flagged after input failure. Input 1. Unit tests are, the purpose of unit tests is to validate the behavior of newly added features one by one to ensure compatibility with existing functionality. Creating robust programs well, not even bounds testing, but with edge and general case testing. Oddish testing. Oddish. Unit tests also will apply to do we call it an integration test? Is it in random? Let's find out. Ow. Is it not in random? It's not. Hold. Oh, oops. It seems like it's biased towards, what's the max? 26, 26, 28. See, 30,000. I don't know, it doesn't seem super random. And it seems like it has a low, what do we call it? Not periodicity, but a low, small values compared to a standard Mersenne Twister, a 19937. Those return big ass numbers. Low, I don't know, low power? With the following test, it looks like and isn't very powerful. Since the max value it generated was 30,000 ish, compared to standard Mersenne Twisters, building much larger values, probably because it takes bigger seeds. But once seeded, it's more believably random values. Periodicity might also be lower for rand. I can't tell yet. 8.10. Okay. Need standard character output. specifically we need an output stream. And then we could do for and we could do a couple things. For an I, whatever, 1 through 5. So initialize with 1. While I is less than or equal to 5. Increment I, and then standard character output I. Run it. Hmm, 8.5. Switch labels cases must be integer or enum constants. Because floating point values are floating point, and other value types are disallowed. The philosophical reasons why, or is it philosophical? The underlying reasons why aren't known to me. Maybe because floating point equivalence could yield its normal errors due to because of how because of what do we call them? Floating point fractions. Fuck, what do they call it? There's a word that describes how because they're represented by what do we call them? What's the word for how floating point values are represented? Oh, binary fractions. Binary fractions, which introduce error when rounding errors. Not sure about using integral values only. It's convenient, avoids rounding errors, and we still have if statements to fall back on for switching on non-integral values. 7.11. Static variable in a function. Oh, a static variable in the function means we have a static local variable, which means its lifetime starts at program start instead of each function call, and it's destroyed at program end instead of the end of local scope or the function call, i.e. its value is prolonged between calls. It's also zero initialized at runtime, and first truly initialized in the first function call. 7.6. Give variables const or const expression qualifiers to give them internal linkage, or put them in unnamed namespaces. The static keyword applies internal linkage to functions to to non-member functions. Yeah. Well, yeah, because well, I guess static member functions are inline, right? Or no, I guess they only get defined in one place, right? Or no, they would be inline. Yeah. Static. If we make a static member function inline, we can include it in header only libraries. I don't think it is, because if it's static, then the linker won't pick it up and we won't get conflict. So we could have a static function in one file and a static in another file. They could do totally different things with no conflict because the linker won't pick them up and see any conflict. The compiler will say valid in this file, valid in this file. The linker will say, are you two valid? And it won't even see them. We're going max schizo mode, holy. Alright. Yeah, it does different stuff to member functions. Local variables live in. I mean, what do we even say? We say. I mean, random access memory, I think. It might normally created in the heap, I think. Haven't learned about it, but could be dynamically allocated in the stack. Be a pushback for a standard vector or treated as a stack. Right? Because we could say there's a standard vector, we don't know the size. Right? That we value initialize, and then we can push back and it will increment the capacity and dynamically allocate it. Since pushback, is it standard pushback? Oh, what needs, whatever, I'll just say 0. No, it's a member function, duh. Okay, I think I'm just tripping. O2. And operator and logic bitwise and returns the binary integer that with bits set to 1 if set to 1 in both binary integer operands and other bits set to 0. since not true in both operands. Oh, one. Sure, we could say U and A T flags. And what do we call it? We say, is it 0B? Fuck, what is it? Alright, and then isn't it UNAT flags GB? Yeah, it is. 0B 0 0 1. Sure. And then we could say flags or equals, so it's itself or 1 left shifted 3. The third bit is bit 4. And we can test. Oh, this could be interesting though. I guess we could just static cast it to an int, right? Or, well, okay. We're gonna say UNAT flags 0B or 0B. Okay, and then we're gonna say flags or equals 1 left shifted 3. And then what are we gonna do? We'll say, don't I just compare it to and equals? So if we say flags and 0B or 0B 0 0 0 0 1 0 0, or we'll hold. That's the problem. We need to get because if we do that, then we at least get, yeah, I think that's fine. What prints? We get 8 because we get 0 2 4 8. Yeah, because this guy gets set. True. And the point is, what, we just output whether it's true or false? So it's true. But if we didn't do this, then it's false here. And there's nothing in common, we get false. Create flags. Set third bit. Bit 4. Counting right, left. if set or not. Print if set. (2.7) Use epsilon to compare difference between double values, or well, to compare or to evaluate how large the difference the absolute value of the difference between two floating point values is. Determine if two floating point values are equivalent. Can't use equivalent, well, shouldn't use the equivalency relational operator equivalence, because binary fractions create rounding errors when floating point values are, what do we say, are not changed, because if it's set to something that's changing it, but it's not increased, decreased, we'll say. (2.6) returns A if, or returns whichever is greater. If A is greater than B, returns A. A returns B otherwise. Or B if equal. Let's just put this in. I gotta go to bed at 50, so. Is that it? That's all we have? Value semantics. Boy, if you don't. Oh, wait, hold. Oh, meaning not. Ow! Meaning not move semantics. Oh, yeah, hair was pinched in the. Ow, fuck. Yeah, that's the feeling. It's pinched. Standard array has value semantics. Copy like built-in array wrapped in a struct, meaning that it's not movable. Well, and regardless, we don't pass by move anyway because we're not passing a temporary. Passing by reference or concept of immutable, avoids copying. Nice. Copying it may be cheap if it's small. Makes sense. Yep. Excuse me. They decay to pointers, meaning if you pass them to a function, you lose the size. Meaning we can use them and I guess get the size, but if we pass them, then we don't know how long they're valid till. They seem kind of dangerous then. I mean, if we had, I mean, like, yeah, like let's just pretend all values in memory have integer values there, right? And then we pass a C-style array of integers somewhere, and then we're evaluating and trying to loop through the whole thing to print to the end. Well, how do we know where the end is? Is there an endline character or like a null terminator? I don't know. Like a standard string or a C-style string? I don't know. I have no idea. If not, how are we supposed to know when it ends if the next piece of memory that's fuck. I'm trying to think of the word for Not consecutive, but the one next door. The piece of memory next to the last element of the C-cell array, if it's also an integer, we're going to print that shit too. Standard array does not decay. Yeah, that's the point. It doesn't decay. It's a proper class type, so it returns that. Yeah, okay, so this is all 100% correct then. You just misinterpreted because it's not the smart version right now. Size and capacity. Motherfucker, we can't, dude, because my integer variable is signed. It's gonna get pissed. Oh, I totally didn't read the capacity part. The number of currently stored elements versus capacity is the reserved slots, which is either greater than or equal to the size, because it can't be less than. We can't have memory not allocated, but also have elements that are valid. Pushback only allocate when the size is greater than the capacity, meaning that when the size becomes greater than the capacity, and the point is because they increment the size. So if we have capacity 5, size 5, and we increment the size, well, now the capacity has to increment, which then we reallocate. Yep. Return value optimization and move semantics allow efficient standard vector returns. Return value optimization. Okay. Still haven't heard of this, but before C++11 often, but it's nearly eliminate the cost for large dynamic containers. Fuck yeah, dude. Move constructors. Nice. Capacity is not always exposed in question about size, but okay. Capsulation breakage. Yeah, because of friends makes sense. Friends should be intentional. Yeah, exactly. Makes sense. Yeah. Oh, I'm just gonna pass it. No, bro, just use the fucking interface. Hello? Public interface. Good. Set members. Inline static can have in class since plus 17. Okay. Oh, and const expression implies inline. Well, I didn't even say that, but I just said or inline. Inline also works, but, and I don't know why it says dot const expression. It shouldn't. Well, if it's, well, I guess it's not, well, yeah, I guess so, huh? If it's a const expression global, yeah, but it doesn't imply inline. I mean, I guess for a class variable, maybe it does. Because it definitely doesn't imply inline, because if we have to make const expression constants inline manually in header-only libraries, or at least in header files that we're including as constants, because otherwise we get separate copies of them for each file that they're included in. Because then it's defined in each file separately, so we get a separate allocation of memory for each copy, which is a waste because it's const expression, it can't change. Why would you waste memory like that? Static locals do get their destructors around. Oh, shit, really? Oh, well, they do, but it's only when they get destroyed once. Brother? The whole point here is I said they don't get the destructors around until they're destroyed, which is not when they get out of scope, unlike everything else that gets destroyed, or unlike every other local variable that gets destroyed at once it exits scope. You're just wrong, bro. In this points to the specific object on which the function is called. Makes sense? It's also invoked implicitly when passing by value. Returning by value. Oh, well, yeah, because it's the copy of the value. Oh, hold, we're saying, yeah, because if we're creating one of some type and we're saying, hey, it's getting the value of another, meaning T2 is T1, assuming that T1 is also a T, then yes. Returning by value or implicitly, well, yeah, because unless we're returning by value, well, oh, I guess we would. If we're returning by value, it's a copy constructor just to create a temporary, which could be a waste. But then maybe the copy gets elided, I'm not sure. Maybe not. Initialize the list. Yeah, instead of initializing in the constructor. What? Constructors prevent partially initialized objects because they guarantee they're all initialized? Oh, meaning like if we don't even call the constructor, then they're default initialized. Yeah, that makes sense. Because otherwise they get value initialized. Or well, I guess they still technically get default initialized. But it at least does it. Otherwise equivalent, structures only data. Good bed shape versus technical. Yeah, good. Okay. Pointer to member instead of fucking dereferencing the pointer to member. Oh, and I guess you could do it either way. I'd prefer to just do oh, I guess you would do it that way, huh? You'd put it in parentheses instead of doing parentheses dereference on the outside, because if you dereference on the outside, I think it's going to dereference the member, which wouldn't be a pointer unless it is. Scoped enum, sure. Yeah, true. And they don't put their enumerators in the same namespace that they're contained or defined in. Unscoped enum, yep. No pointer. Okay, that's right. Doesn't resolve the int like that. It's type safe. Okay. No pointer is a type safe value, but I'm just gonna say it's a pointer to nothing. Just like the address of something is a pointer to that object, not actually the address itself. Const means hold. Wait. Const guarantees if possible means read only at runtime. What does that even mean? You fucking idiot, bro. This is not the right section to put in const expression and const. I knew it was gonna say this shit. Const is not relevant usually for functions. It's relevant for objects. And if we're talking about const expression versus const objects, yes, a const object is read-only after it's initialized. Const expression is read-only from compile time, yes. But for functions, which is the chapter this is included in, this is not relevant. Uh-oh, hold. Oh, totally true, because the parameter is also called min and max. That was my bad. It should have just been A and B. That was my bad. They don't shadow each other, but they do fuck up here, because it should just be min, max, min, max, min, max. Boom. Whoops. I did definitely put the wrong name though here. Turn type alone. Yes, they must different parameters too. Makes sense. Yeah, if it fails, it says the flag is true. Isolate each integration. It is integration testing. Cool. Makes sense. I should have said integration testing too at the end, but I think unit testing isolates each module, and then once we put it all together, then integration testing. Okay. So we run unit testing to get the result to see, hey, can this thing hit this? Oh, okay. Now we're putting it in. Now the character can actually hit something. Can the character hit something? Oh shit. Can the character hit another valid thing? Oh shit. Oh, everything. Okay, so range just sucks ass all in all. Low periodicity, poor randomness, small range, and it's also global state instead of it being specific somewhere else. I don't know what it depends on though. I don't know if it's just each call changes the state or if it depends on other things too that makes it worse. The for loop. Ow! Ow! The freaking hairs get caught. For loop. Switch on ints. Floating point has a quality issue. Switch needs constant integer labels. Makes sense, yeah. Did I find destruction at program termination? Yeah, you motherfucker. And then, uh-oh, hold. Never mind, not stack or heap. Okay, I was wrong about that part. Good. Static at global scope is internal linkage. Constant const expression at global scope. Default to internal linkage. Hold. What? What are you talking about? Constant const expression at global scope. Oh, well, okay, sure. I should have said a global scope specifically because if we're talking local, well, guess what? There's no linkage for local variables. None. Can't be accessed anywhere except in their own function. Okay, I was right. Local variables live on the stack, not the heap, so they're actually dynamically allocated and then destroyed after. I don't know how the heap works. The heap is for dynamic, so it's actually the stack at the bottom and the heap at the top. Never mind. Heap is for dynamic. Maybe mix the idea. Pushback is actually the heap. Never mind. The vector's elements, not the loop counter. Okay, I don't know what you're talking about. The loop counter. Nobody's talking about loop counter. I'm talking about incrementing the size. Yeah, I don't know what you're saying there. Bitwise and off by 1 bit. Bit means that. Oh, so it should have been left by 2. Okay, never mind. My bad. Bit 3 is still. Well, you said hold. What did you say? Well, let me finish this. Hold. Epsilon conditional. Cool. Yeah, makes sense. 0, 1. The third bit. Oh, okay. The third bit actually is the first bit, the second bit, the third bit. Never mind. You didn't say bit 3. It's bit index 2, I guess. Or depends how we're going. I guess bit 5 maybe. 0, 1, 2, 3, 4. Or hold 4, 5, 6, 7. So it's 4. Or hold on. Oh, yeah, it is 5. Okay, my bad. So the third bit is actually first, second, third. Yeah, because we're not gonna say the zeroed. We say the first, second, third. Okay, so it's 0, 1, 2. Okay, my bad. So it should have been left 2. Okay, cool. I'm basically good on all fronts. Just need to work on some semantics. You know, I like that. I like the big concrete test like that once every 3 days. It's like not one day, and maybe even not a third day, and then on the 4th day. I'm gonna do that now, I think. And then if I start fucking up, then maybe we can increase it every other day or every 2 days, whatever. All right, bye.